So for this problem, we're going to graph this exponential function here and then describe those 7 things that are up there. You can do these graphs one of 2 ways. You could make an XY table, or you could go through and do the transformations based on the parent function, which is what I'm going to go through and do. So for problem C here, we have y equals 5 to the x minus 2. If I'm going to use the parent function idea to go through and do this graphing, our parent function equation is going to be y is equal to, and we use the same base here. So y equals 5 to the x would be the equation of the parent function for function h. So I want to visualize, I want to think about what the parent function y equals 5 to the x would look like. There are 3 things that we are graphing when we do these parent functions. One of them is that all of the parent functions, no matter what the base is, all have a y-intercept at 1, so they go through the point 0, 1. They also go through the point 1 comma and then the base. So depending on the base, that point does change. This one has a base of 5, so it's going to go through the point 1 comma 5, and then all of them also have a horizontal asymptote right on top of the x-axis, and the equation for that is y is equal to 0. So with that in mind, I can come up with a quick little sketch of this, and again, this is something you could just kind of visualize as you are doing this problem. You wouldn't have to sketch the parent function in order to do this problem. So y equals 5 to the x has a y-intercept at 1, so that's going to hit here. Goes through the point 1 comma and then the base, and the base is 5. So it goes through the point 1, 5, and it goes through the point 0, 1. And then the other feature of our graph is actually not part of the graph at all, and it is a horizontal asymptote, which is, for the parent functions, always right on top of our x-axis. From there, we just need to know the shape, and our graph is going to be very close to that horizontal asymptote, just a little bit above it over on the left side. As we go to the right, it's going to gently go upward and go through those 2 points, and then get steeper and steeper and steeper further over to the right we get. But this graph will continue to go over to the right and up and over to the right and up and over to the right and up for forever. So this is the parent function, y equals 5 to the x power, and what a sketch of that would look like. If I know what that looks like, then I can just take a look at any addition or subtraction that we have in the problem. In this case, we just have subtraction in one place, and that will be a transformation. That's going to slide our graph either up or down or left or right. If the addition or subtraction is after the base and the exponent, then that's a vertical shift. Plus is up and minus is down. So we are going to slide our graph down 2 units because of that minus 2 that's there. Up in the exponent, we don't have any addition or subtraction. It's just an x, so we don't have any horizontal shift left or right. So if I take this parent function graph, y equals 5 to the x, and then slide it down 2 units, that will be the graph of function h. Okay, so let's graph y equals 5 to the x minus 2. I'm literally going to take the 3 features of this graph, the 2 points and the horizontal asymptote, and I'm going to slide them all down 2 units to come up with our final graph for function h. Let me start with the points. I have a point here at 0, 1. That would be here on our graph, and if I move that down 2 units, that would be here. So one of the points on our final graph is actually going to be at the point 0 comma negative 1. Another point on the parent function is the point 1, 5, but I need to move that down 2 units. So if I move that down 2 units, that would give me a point right here at the point 1 comma 3. And then our horizontal asymptote is here right on top of our x-axis. I also want to slide that down 2 units. So if I take that horizontal line, bump that down 2 units, we would have a horizontal asymptote that would cross the y-axis at -2. And then from there, we're just going to draw in the shape. We could come up with more points, but with 2 points in the asymptote, we should be able to come up with a pretty accurate graph. So we end up with something that looks like this for our final answer for the graphing part of that problem. Exactly like the parent function, except moved it down 2 units. From there, we are also supposed to describe, we'll do that mathematically more than in words, 7 things: the domain, the range, and the asymptote are 3 of those things. After you do a few of these, a lot of these blanks you can fill in before you even do the graph. All of these exponential graphs are going to go forever to the left. That's pretty obvious. But they also go forever to the right. As they're going to the right, they do go upward very, very quickly. But this graph is going to continue going to the right and up and right and up and right and up. So it goes forever to the left and forever to the right. The domain of every single problem that is an exponential like this is going to be all real numbers. The asymptote. Well, the parent function asymptote starts on the x-axis at y is equal to 0, and then we moved it down 2 units, down to -2. So any vertical shift that you have here is actually going to be where your horizontal asymptote is going to be. So for this problem, I could do y equals, because I know it's a horizontal line, and then whatever the vertical shift is here, that is going to always give you the equation for the asymptote. Or you can take a look at the graph. The range, I'm going to copy the y and the -2 down again. And we just look at the graph, and the graph is all completely and totally above the asymptote. So we're looking at bigger y values than where the asymptote is. So we're going to have a greater than in between there. In addition to those 3 things, we're supposed to list out the end behavior at both ends, the left end and the right end. We're supposed to list out the behavior of the graph using limits. Your limit notation always starts out with LIM, and then underneath that we need to describe where we are going. What part of the graph are we looking at as far as our x values go? And for the left end behavior, we're going over to the left as far as we can, which is towards -infinity. And then we just need to describe what's happening to the height when we do that. When we go to the left as far as we can go, the height is getting very, very, very close to the asymptote. So it's getting very, very close to a height of -2. For your right end behavior, again, we always start with LIM. And then we want to go over to the right as far as we can. And this graph does go to the right for forever. It also goes up really, really steep, but it goes to the right and up and right and up. So it goes to the right for forever. So when we're doing the right end limit, we're looking at the limit as x approaches +infinity. And what happens to the height of our graph when we do that? Well, as we go to the right as far as we can, the graph goes up to +infinity. So there are our end behaviors using limits. As we go to the left as far as we can go, to -infinity, our graph gets really close to a height of -2. As we go to the right as far as we can go, +infinity, our graph goes up for forever also. Last thing we need to do is list out where our graph is increasing or decreasing. And for those 2 features, you just need to know that your 2 answers here are going to be the domain for one of them, and the other is going to be none. These exponential graphs either increase the entire time or decrease the entire time. There's never a mixture of the 2. So the 2 answers are going to be everything, or the domain, and none. And as you go along the graph from left to right, when you're doing increasing and decreasing, you always want to go across the graph from left to right. Read it kind of like a book. As you're reading this from left to right, the graph is slowly going upward. It's slowly increasing to start with. And then as you go to the right, it starts increasing at a faster rate. So it is increasing everywhere. So I copy the domain down there, and it is not decreasing anywhere on the graph at all. As you go along this graph from left to right, it only goes upward. It does not go downward.